on this computer.
Uh-oh.
Okay, so now, oh, did I lose something? Speaker view. There we go. I think I can get this. There, okay. Before I dive into too much here, does anybody have any questions on stuff that Travis has got a bunch of questions, but he's out of luck.
I used to know sign language.
Gonna have to use the chat window, I guess.
Oh, there you go.
Mic not working, bought a new camera, didn't have a chance to fix things. Didn't get the email reminder set. That's okay, because you know what? I'm not that impressed with my my introduction to joints right now, because I didn't have as much time in preparation as I should have. Even though I had 2 weeks this time around, I kind of procrastinated a little bit. And we were talking about the other CAD systems, and in Assemblies and in making, in constraining components in Assemblies, Fusion 360 does have a different paradigm than SolidWorks and similar programs do. In SolidWorks and similar programs, we have a process where we apply constraints. So we take something that's free and we apply individual constraints until we get the right level of constraint and remaining freedom in a component so that it can move as we want it to move.
Can't you do that in Fusion 360 as
well? You can, but the way you approach it generally is a little bit different, in that the thinking mode is you lock it down and then you tell it what freedom you want to give it. So when you define a joint, you're defining just that joint, and you're not explicitly locking down other forms. And so it takes a little bit of getting used to, but I think it's actually it's a simpler, more intuitive approach. It's a better approach, I think, for this kind of package. The only thing is, when you've been doing the same thing for 25 years, you have to break your old habits and learn the new approach. And that's a little bit of what I'm struggling with. Did anybody run into any issues with importing devices, importing components, importing elements after 2 weeks ago? Any questions based on that? Anything else coming up?
I was able to import a couple of things and it worked just fine.
Okay.
I mean, you always have to move things once it's imported, but there's no way around that.
Right.
Other than to move it.
Sam, you were going to say something?
No, I really haven't imported very many things. So the only things I've imported are STL files, and so that's, I haven't been there yet.
Okay. Well, one of the things that we did 2 weeks ago when we were importing things that was a little bit clunky is we used the align feature a lot to try and place things. And that's kind of back to the SolidWorks approach of applying a constraint. But it's not the greatest, because align creates a temporary movement, and it doesn't create a parametric link. So things can get moved around later and you lose that alignment reality. And so really joints is the better way to do these kinds of assemblies. And can you see my screen?
Yes.
Okay, so this is a simplified version of the Ortur laser, and there's a bunch of elements that are still kind of missing from it, but the main functional moving parts are there. I thought this would be a good one to work with since a lot of us have one. However, it's not the best for demonstrating a lot of different kinds of joints. So I'll just kind of play around with it a little bit and do a few things that give us different kinds of joints.
So did you create that 80-20 part yourself?
Which one? The
bar, the black bar, and
the black bar.
Going down the center.
Yeah, the black bar I did. Yes, I found one online and I downloaded it, but I didn't like it. It was not exactly the same, or it was a poor representation, one or the other. So I just got out my calipers and made a bunch of measurements and made my own extrusion. I did, however, the fan I downloaded, the stepper motors I downloaded. So I got to the stepper motors by using the insert a manufacturer part. And I think I went over this 2 weeks ago. It's a little bit clunky. It's kind of hard to find. You're best off if you know a manufacturer and you go find their component, or if you have a catalog number or something. If you're just doing a search on stepper motors, for example, it's really difficult to find. You kind of got to play around with it a little bit till you figure it out. But I did find one and downloaded it, and it's that's what I'm using here. It's a fairly simplistic model, but it works. I wouldn't render as good as some of the other models would have, but it fits the bill for now. Now, one of the things I did as I built this model, I kind of made sub-assemblies. Even though I didn't use joints, I didn't use assembly techniques, I kind of did everything design in place. But I did break them into the key assemblies that move separately from each other. The laser carriage assembly, it can move up and down on the focusing screws. The laser mount assembly carries the laser and it goes back and forth on the x-axis. The X-rail assembly is one rigid assembly that moves back and forth on the base assembly, or the y-axis. So that was just my organization, and typically, like 2 weeks ago, as I go through and bring in a component, a quarter of the time or so, I've forgotten which element was activated, and so the new imported component went to the wrong place, and you can just drag and drop, and that's really convenient. So you try and stay on top of it, and you try and make sure that you've got the correct level activated. But if you do make an error, it's pretty easy to recover from. So what I'm going to do right now, I'm going to start with the base assembly. So the base assembly that I have here is just 3 parts. It's the extrusion and the 2 side feet, or legs I call them, I think. If I open this assembly, let's see, I have the Y rail and leg 1 and leg 2, even though in reality they're not exactly the same. I can make a copy and then edit one of them to be different when I get to that stage. But in this case, I built the Y rail first and then built one leg by sketching on the edge plane of the extrusion, and then copied it over. So these 3 parts are correctly located in space, but they're not rigid. If I grab one part, it goes wherever. So there's no assembly intelligence here. And there's a couple things that we can do when we've got an as-designed assembly, or a lot of cases when we import an assembly, like a step assembly. it's effectively in this state. All the components are there, they're all in the right places, but they don't have any intelligence about staying there or how they're assembled. And where I've seen this a lot is when I import a circuit board into a product, because often I'll get the circuit board design. I might do a circuit board outline and place critical components. Then I'll send that to the PCB designer. He'll design a whole circuit board. He'll export a 3D model. I'll get it. And when I get it, I have to be careful because those parts have no relation to each other and weird things can happen. So basically, there's a couple tools we have to lock things down in place when they've been designed in place like this or imported. And one of the simplest ones is a rigid group. So a rigid group locks components together relative to each other. So I'm going to say rigid group, and I'm going to select the base assembly and all its child components. You'll see it grabs the child components. And I say, okay. Now, when I grab a leg and try and move it, the whole thing moves because it's one rigid subassembly, a rigid group. And that's the first step of capturing some of your design intent here. Another thing that's relevant to making movements is deciding what's your fixed component. And in the case of this laser device, what we're looking at right here is effectively the non-movable base compared to the rest of the part. Yes, we move the whole thing around, but this is sort of the base part. And so what we do to capture that in assembly mode is we right, I made a mistake there, I didn't mean to do that. If we right click on the device, we get an option to do a number of things. And one of them is called ground. So if we ground this component, that means it's not going to move. I can't, if I grab it and try and move it right now, it doesn't move. It's grounded, it's fixed, it's tied down to earth.
Tim, does it ground it with respect to an origin? I know the bottom plane is probably parallel to the XY plane, but does it force it to be on the XY plane, or does it just freeze it wherever it happened to be in place?
It freezes it wherever it happened to be. So I could have moved it and saved the location before I grounded it, and then it would be grounded in the new location. I think it might give me a warning, but that's in fact what I do. In fact, let's see what happens like that. If I unground and then I move this, now when I go to ground it, it comes and tells me some components have been moved. Do I want to capture this position or continue in the previous position? In this case, I want to go to the previous position because my other components are still floating in space relative to where it was. Now, we're looking at joints and assembly after we've created all these components, but in reality, we could be using joints as we go along. And it does make assembly easier and it follows our design intent better. So we really should be doing that. Last week, when we were importing components, would have been better to use joints, but two reasons we didn't do it. One is I hadn't done my homework, and B is I didn't want to introduce joints yet. So for example, right now I'm going to stick, I've got some mounting holes here in the legs that go into holes in the extrusion. So I'm going to insert from McMaster Carr a fastener. I'm going to go round-headed Phillips round-headed, metric, M5 by 20, passivated. There it is, $9 for 50 of them. And I'm going to save as a step file. And when you first go to McMaster-Carr, that might not be the default. It's just because I've previously been using McMaster-Carr, so it's going to the last file approach that I used. Okay, so there's my component. As usual, it's not where I want it to be. So I could go through the, the motions of moving it, rotating it to orient it, and then moving it over to where we want it to be. But what I'd rather do actually is use a joint anyways. So what I'm going to do is I'm going to assemble using a joint. And right now it tells me that I moved the screw. I'm going to say capture position because I want to do my operations from here rather than where it was. I could do it either way. Now we have component 1, component 2. Component 1 should be the component you want to move into place. So first, select on the component you want to move into place. So I'm going to spin this around because what I want to do is use the inside of this screw head to create a joint. So you'll notice that as I move the cursor around, there's this little semicircular smiley face laughing at LFMAO or Pac-Man or whatever it is, and it's looking for things to snap to. Now what I'd like to snap to is the centerpiece. See that when I'm on this surface, it shows me various key points that I can use to key onto. And I see one at the very center of the circle, and that's the one I want. But when I go there, the threads get in the way. Now it wants to pick the threads. I don't want the threads. So there's a little trick here. I go to the surface that I want to use, and on Windows, I use Control. On Mac, I use the Command button. And when I do that, it locks it to this surface. Now when I move, it only allows the handles of that surface to be selectable for me. Does that make sense? Did you catch that?
Yeah, so when you held down the command or control, you were basically saying, at least know now that we're talking about this surface, and then you guided the cursor to select where on that surface the threads didn't surface, and so you could get to the center. Is that the logic?
Exactly. Okay.
Okay.
That's exactly it, and it's a key point because it gets really annoying otherwise. So I've selected that. Now the screw has kind of gone a little bit translucent on me because it's been selected. This is locked, and it shows a joint, a rigid joint about ready to be created. Now, what do I want to join that to? Well, I'm going to spin this around, and for component 2, now I can come right up and I want to get the center of this hole. Okay? I don't want to get somewhere else. I want to get the center of the hole here. And when I do that,
You want the center of that hole, but you also want the plane that has been highlighted, right?
I want this plane here, yes. So I could do the same thing just to be absolutely sure. I can hold my command button, come over here, and select this. Boom. There it goes. Okay.
Tim, you said command, and I thought you said control before, or did I misunderstand?
Control for Windows, Command for Mac. Or to make it more confusing, if you're doing like I am and using a Windows cordless keyboard with a Mac, then it's the Windows button.
Hey, Tim, you've got a bush on your head. Did you know that?
Yeah, I'm going for the coronavirus appearance. What little cone curls?
There are very few people that I have actually been able to watch progress to being overtaken by their hair. It's pretty impressive, man.
Keep watching. So this defaulted to a rigid joint because that was the last joint type that I used. And in this case, that's probably the best joint type to represent this fastener being in place. However,
when you chose rigid, was it a drop-down menu?
No, it defaulted. Here's the drop-down though.
Okay, so rigid was the last you'd used. Okay.
Correct, yeah. Now if I go with Revolute, then it allows the screw to spin in place. Which only works if the threads have been stripped, you know?
Yeah.
If I use slider, then it's going to slide back and forth. If I use cylindrical, then it's going to do both of those two. It's going to slide and turn. If I use pin slot, doesn't really work in this case. It's like a type of slider. And I'm not even sure what planar here means. It can move anywhere in the plane. And a ball joint is going to revolve about that point.
That's pretty cool.
So in this case, what we have in mind is rigid. Okay.
Tim, there's a variable right next to where you chose rigid, and yet 0 seems like the only appropriate number there if it's really rigid.
Let's edit this joint. So we're going to come in to this joint here. Let's edit it. And let's see, there's an offset there. Let's make the offset 10. It doesn't really, actually, yeah, you're right, it doesn't make sense. Certainly not in X, but we could create a joint there and actually give it an offset, maybe say in Z, sorry, we could do like a 2 millimeter offset if that somehow made sense.
Yeah, got it. Okay. Okay.
All right.
Thanks.
Okay, in fact, I'm going to keep playing with this one because it kind of demonstrates it a little bit, almost a bit easier than some of the other stuff. So let's say we change this to be a slider joint. If we go to the motion, yeah, we can animate, we see it. But one of the things we can do, so if we've done that, now anytime we come here, we can grab this screw with the mouse cursor and just move it around like that. But maybe we want to constrain it, because right now it can go wherever it wants to. And sometimes we use this for things like exploded views.
Oh, okay. And the constraint you would put on it was simply the range of movement?
Correct.
Okay.
So if we edit the joint limits, we can create a minimum, a maximum, and a rest if we want. So we can say the minimum in one direction is 0, and the other direction is 10. And for grins, let's make the rest 3. Okay, so what this means is it's going to stay at the 3 position when we do nothing else, because that's at rest. We can pull it out to 10, but no further. It won't come any further. If I take it and push it in, it'll only go to 0. I can't take it any further. And when I release, it's going to pop back to its rest position.
Cool.
Nice.
Just give me just a second here.
That was slider, right?
Yeah, so that's the slider. Let's edit this joint again. We can, what else? Oh, if when we had assembled it, if the orientation wasn't what we had in mind, well, obviously we would hit flip. That's pretty standard. Now if we animate, it's only going to animate within those limits. Okay. And so
It looks as though it has 2 little white lines that might also show the rest position too. You see those 2 white lines?
Are they showing the rest position or just the fact that it's a slide joint? I'm going to go back to editing the limits, and I'm going to take off the rest.
Yeah.
Now what happens is when I move it, it'll stay wherever I left it.
Yeah, and it also indicates that that was simply a way of showing it was a slider. The
Correct.
2 white lines.
Yeah. 2 white lines and the little blue arrow.
Yeah.
The blue arrow is showing us the direction of positive displacement.
Oh, okay.
Right? And if we want to, we can, if we don't want to see that, we just turn the visibility on joints off. Right, so that kind of gives you the, how to use a joint to assemble components, or this type of component. There can be some other ones. There's a couple of, again, good YouTube videos on the subject. I can maybe include, when I put the link to this video, I think I'll include a link to one of the other videos that's pretty good on this for some motion.
Is there a fast way to repeat that operation on a bunch of holes without going through the whole process? Like you'd like to say, okay, so I've selected this surface on the screw. Now duplicate the screw and put it in this hole and this hole and this hole and this hole. And
yeah, in this is one of the places where if there is, I haven't found it yet, and I've been looking for it because on CAD packages I've used before, first of all, that was very easy to do. And second of all, parametrically, you could actually define these holes with a variable and then say, take this screw and assemble a copy in each one of the holes that are labeled as such. And boom, it just does them all, right? And then, oh, I changed my mind, take the screw out, put a different screw in, boom, it does them all, right? So that level of automation, I'm impressed that you went there.
that would be good.
It's available in high-end packages. I haven't found a way to do it here yet. I don't think there is. If I do a copy, okay, first of all, now this was created at the top assembly. Like I said, I inserted it at the wrong place. I'm just going to drag it in there. And now it's in base assembly. Now,
Hey, Tim?
yeah.
No, I want to wait until you get done with this. Go ahead. Sorry.
Yeah, what I would do here, typically move copy, select that, create a copy, and then move it, and then yeah, have to go through the
Definition process. Yeah.
the joint again. Yeah, assemble with the joint, and I haven't found a way to do what Sam's suggesting, and it's an excellent question because it really should be available to do, but I'm not aware of.
It's almost like the right click sweep up, would
Oh, right, yeah.
repeat the operation or something, in a new place, and that'd be nice.
Oh, and actually, I misspoke earlier. I said that the joint type was going to the last joint type that I used. That's not correct. It's guessing at what the joint type's going to be in this case. And so it's making its best guess. Sometimes it's right, sometimes it's wrong.
So Tim, at the macro level, I think what you've done in this assemblies area is talk about one function joint, and it sounded as though the macro workflow was component 1 to component 2 and define the relationship. Is that kind of the way the flow is?
That's correct. So component 1 being the component whose location is not yet defined. Component 2 being the home location for component 1. And then the specifics, the type of joint, the limits, those kinds of things, yes.
Can you tell us, you know how we were talking about in the first screw that the 2 white lines with the arrowhead were indicative of slider with the positive direction? Look at the other screw.
So that's a rigid joint.
Oh, so it's fixed.
So you see those locked teeth? That means rigid.
Yeah.
So
like a box joint or something.
Correct. So if we, let me see here. Again, I've got to move this in.
So it didn't have all the attributes of the last one when you copied it.
Right. So I just took the default rigid. I didn't go in and edit it.
Got it. Okay.
So if I edit joint, I can change it with the pull down.
Right.
And if I change it, then you'll have the revolute symbol instead. You see the little symbol beside the menu?
I do now. Yes. Thank you.
Yeah, no worries. That's how that's going to work.
Okay.
Okay. Now, the other thing about, well, actually, before I go further, any questions on what you've done so far, or usefulness or annoyances of these various approaches?
Yeah. Well, why didn't you choose the black screw?
Because my Ortur had a shiny one.
Oh, okay. You want it to be reality. Okay, got it.
But I have been assigning materials to most of these elements. So I've got aluminum, and then I did a color variant for anodized black aluminum. And then I'm using black acrylic here and white acetal for the spacers, etc. And the reason for doing that is if you, in theory, when you design something like this, you can get the material properties. Now let's see, at what level can I get properties? Right here. So it's going to run properties, and hopefully I don't regret making that request in a more complicated assembly on a powered computer. Here it is. So this is telling me that this thing weighs 2.788 grams. I don't think so. So something's not right there. I'm guessing that it's the model for the laser. It's probably modeled as a relatively solid block of something that might not even necessarily be aluminum. So, but if I had done it right, I would be able to get correct mass, location of the center of gravity, those kinds, center of mass, those kinds of things. Moment of inertia.
Center of gravity. Oh my God.
Well, maybe you're designing a boat, and your center of gravity and your center of buoyancy are critical factors.
Yeah, they would be. It's amazing it can do that. Wow.
At some point, we're going to do a little boat design, just for the fun of it.
All right.
Okay, well, that's all well and good. We've got this base assembly, and it's locked in place. I can't move it around anymore. But onto the base assembly, we have this X-rail assembly. And it's not entirely complete. The belt's missing and a bunch of other things. I didn't get that far yet. But I do have the roller wheels on it and the stepper motors that I imported, and et cetera, et cetera. And things are in approximately the correct locations. Now, again, these aren't locked down. If I grab a part, I can move it anywhere. So what I'm going to do is I'm going to turn off the base assembly because everything is in the location I want it to be right now. And so I'm going to create another rigid group. So I'm going to go to Assemble, say rigid group, and I'm going to select the X-rail assembly, including child components, and say OK. Now if I've done it right, when I try and move the rail, the whole thing moves. It's all together as a rigid assembly. And of course you're going to say, wait, Tim, the wheels are supposed to spin. That's true.
Wait, Tim.
So, but for the purposes of the XY motion that we're doing here, when the wheels spin, they don't look any different. So there's really no point having the wheels spin. If there were spokes or tread or something, it'd look cool. But you're not even going to see anything in this case. So we can approximate the model to keep things simple as everything here is being rigid. And we'll model it as though the extrusions and the wheels slide past each other rather than roll. Not perfectly accurate, but much simpler and adequate for the purposes of modeling the XY motion of the device. Okay, so now I'm going to turn the base assembly back on, but remember I can still move this and I can move it anyway. Doesn't really make sense. So let's revert this and let's come up with a way to, I would say, constrain this subassembly here to move back and forth on the Y rail. And again, the way we do this is with a type of joint. But in this case, everything's already kind of built. So we use something called an as-built joint. Now, the as-built joint I found to be a little bit problematic, and I hit about 50% of getting the results I want the first time I tried things. So I'm going to select, first of all, the X-rail component that I want to move relative to the base assembly. Now, it's not letting me, it's letting me select the type. If I say rigid, then it's good and ready to go, but that's not what I want. I want it to move. So I'm going to go back and change that to, in fact, slider, which is what I want. So I want this to slide back and forth. And it's asking for position. So in this case, I'm going to come in and I'm going to grab a flat surface that is normal to the direction of motion. Okay? And now when it does the animation, because it's an as-built, it doesn't move everything around. It just kind of moves this arrow. It's a little bit less useful, but it does at least show me that it's the right direction. I'm going to say okay. And then I'm going to see what happens here. So if I grab this, now I can't move it up and down. I can only move it side to side. So what I did was I told it the direction normal to which it must move. And by default, it constrained all the other directions.
So Tim, as you do this, you're not thinking at all about the reality of how this would function. Because when you started this out, I was thinking wheel and 80-20 and the relationship between them. Instead, you were saying I have two of my four components, and they're going to have a relationship relative to one another. I could have chosen any surface parallel to the one that you chose and constrained it similarly so that it outwardly looked like it was behaving correctly, but it was really just defining how the two components worked relative to one another.
Correct.
Okay.
So if I were designing something like this from scratch and I really wanted to analyze all the motion, then I should do exactly what you're saying. The wheel should turn, the wheel offset should matter, and I should do that as I go along. When I'm capturing something or I've imported an assembly and all that stuff's there already, but it's just sitting in space, this is a much more efficient way to capture the rudimentary design intent.
So
Yeah,
what
totally
would
get that.
happen if you had a curved rail on the base? Would it have followed the curve, or would it have just gone in a linear fashion?
It would have gone in a linear fashion. That's a really good point.
Okay.
Where would that curve have been, Sam?
If the rail had been curved.
The base track was curved instead of straight,
Oh,
would it have
okay,
followed
okay.
the curve or not?
Right,
That's
got
what
it.
was my question.
And the answer is it wouldn't have. What you need to do in a case like that, if it's a constant radius, then you need to define a resolute joint,
Okay.
right?
But there's not a way to say that the wheel surface and the rail surface should.
There should be, because certainly there's other features like there's other features where we did things like followed a curve with a cutout or an extrusion.
Right.
On animation, I didn't see it. It's not immediately obvious to me where that would be. But I think there's an exercise using a belt that may show that happening. I'm going to dig into that a little bit. I'm not entirely sure if there's a way to do it or not. You would think there would be.
Well,
you
and
might
I
want
know
to
for a fact that
simulate.
Sam's intention is to get into making roller coaster designs, so it's really important that he learn how to do this.
No, it's really that you want to model something and simulate it to see if there are things that get in the way and keep it from moving the way you want, and one of the things about this CAD thing is that you can do things like that.
There should be. I'll dig into that a little bit because I do like that idea, and I think there should be one. There's also, when you put in movement limits, depending on how the joint's been defined, you can use surfaces to be limits.
Oh.
Which represents reality. It takes a bit more calculation. And so
when we did the screw, we had set limits in terms of millimeters. So in theory, if we wanted to have this rail stop at the ends of the rail where you have the feet, you would have had to put in the millimeters after having measured from your starting point. But you're saying we could define the planes that are the inside faces of the legs as limits?
Yes. Now, I know you can do it. Let's see how to do it.
Yeah,
We're going to have to
Yeah,
explore
I mean,
this.
I'm not asking you to do it. I'm just asking for the concept, that's all.
Yeah, there is a way to do that.
Okay, cool.
I haven't done it
So
yet.
getting to Sam's point, that's like, if you think in terms of reality, that's a much more intuitive way to define the flow. You know what you want that X-axis rail to do on the Y-axis, and you know that you're going to be within some distance of those planes, maybe because the end stop, the mini switches are standing out 2 millimeters or something like that. So you say plane minus 2 millimeters to define just the way it would really be if you'd built the thing.
exactly.
Yeah,
Because otherwise, if you extended the rails, it wouldn't work anymore unless you defined it as the surfaces.
yeah. I
Right
mean,
now, Tim, you can take it off the rail, right? Can you take it off the rail right now?
yeah. So right now, in fact, I can take this right off the rail.
Yeah.
Right.
Yeah.
So the more that the motion is constrained by reality, the more useful it is as simulation. Obviously, that's Sam's point, I think. And it's an absolutely valid, a very, very good valid point. So, what I do for a simple little simulation like this to keep things a little easier is I'll go to the joint limits on this slider, and let's say I'm going to set a minimum as minus 30 and plus 120. What's it? It's 150 or is it 140 millimeters?
What does it do? 300 by 300? What is the
No, it's
range on Ortur?
I think it's like 150 by 160.
Yeah, I think it's
Okay,
150.
yeah. Okay, good.
So now we've got 150, but did I guess correctly? I didn't. And what I really should do is measure. So let me measure from here to what's going to hit first. I guess the wheel. And that distance is, minimum distance is 59, so there's almost 60 there. Whoops. Let's change those limits. To be like minus 80 and plus 70. Does that make sense?
I think you have to take into account the width of the device too.
Yeah, so where are the stops on this thing? Oh yeah, the stops are out there a little ways. So yeah, we could measure that and tweak it to be to reflect reality. Again, if we were designing something from scratch, as Sam says, we'd want the real limits to stop things and show us what's going to crash. Usually you can do an interference analysis if you design something and you have interferences where two of your components are in the same space when they're not supposed to be, attempting to occupy the same space, but they can't really. Okay, so that is actually not that far off. So then I'm going to do the same thing again, except this time I'm actually going to turn off the base, and I'm going to turn on the laser mount assembly.
Tim, with the base turned off, could you still go up and down the y-axis, and would it still stop even though the base is hidden now?
Mhm.
So basically, why is this not? It should allow me to grab it and move, but it's not. Huh, that's interesting. When the base assembly is there, I can. Well, that's a discovery. If I turn the base assembly off, oh, now it moves. I'm not sure why it wasn't moving. So yeah, it's the constraint remains. All I've done is turn off the visibility of the other part. And I just turn it off for convenience sake. So I'm gonna revert position so that, because when I revert position, now my carriage, this laser mount is in the right location for me. So again, what I'm going to do, I'm going to turn off the X-rail assembly. Now everything on here is basically locked. So I'm going to call it a rigid group. Oops, I'll just grab the laser mount assembly. Okay, now it's a rigid group. By the way, I should be saving once in a while. And I'll turn on the X-rail assembly again. And now I'm going to use an as-built joint. The slider joint, I'm going to have the laser mount assembly move along the X-rail. And for position, I'm going to pick a plane that's looking this way. And now what I want to do is, let's see if I can be smarter about it this time. If I move it, which point does it, right? Well, actually I can't tell to the laser's on there because it's the laser that hits, isn't it? Oh, no, it isn't.
No, it's an end stop. It's an end stop that's mounted on the...
This edge hits the limit switch.
Yeah.
I don't exactly know, because I haven't modeled the limit switch on there, how far out it sticks. Not very far. About like that.
Yeah, it's tiny.
So does it, now if I say, edit joint limits, it'd be nice if it told me where it was.
Actually, Tim, when you did it for the X-axis on the X-rail and the Y-rail, you defined it from the position that it was on the rail. If you're already, let's assume right now that your laser mount is positioned right at the X0 position because it's up against the limit switch. Would you end up defining then only a range in the direction, the positive direction, maybe the 150 millimeters that we have in that direction?
Yes, if I had defined it there, that would be the case.
Got it, okay. So you basically say 1 is 0, presume 0, and then just the limit in one direction.
Correct.
Got it, okay.
So let's say minus 70. Whoops, not 700. Minus 70 plus 80. Okay, is that right? Oops. Not quite. So,
And that's because you already picked the plane when it was in a different position, right?
right. So what I really should do again, instead of doing trial and error, I should measure.
Yeah.
I should say, what's the distance from, where did I do it? From here, from this plane
Yeah.
to this plane. Well,
Yeah.
it's 44. So let's make it, let's say the limit switch is 4.7. And so let's change the limits to be minus 40. And 120. Now, when I move this way, it should stop in theory.
Oops.
Did I go the wrong direction?
Yeah, it's probably it. Yeah. Yeah.
Let's try minus 120 and plus 40. 40.
Why is that minus though? I mean, at least in terms of the way the gantry, actually the XY axis is in the way the laser works, the positive direction would be to the right.
Its positive direction is away from the surface that I picked when I defined the joint.
Ah, right. We see the arrowhead direction. Got it. Got it. Yep.
Okay, so now if I turn on the base, the interesting thing is I can move in both X and Y.
That's pretty cool, Tim.
Now, the next thing I'm going to do is turn on the laser assembly itself. And again, everything here locks together. So I'm going to do as a rigid group, continue the laser carriage assembly. There's already a joint in there, that's okay. And say okay,
Hey,
and
Tim,
there it is.
in reality, most of the time, the only movement people will do on Z is at the lens, right?
You will focus it, yeah.
Yeah, yeah.
And
I
so,
think you're about to. Go ahead.
yeah, so it's, you could lock it down and then just have a parameter for the focus adjust and then just change that parameter to represent focus.
Yeah, okay.
In fact, that's a really good idea. Let's try that. I like that idea. So let's create a parameter, and it's going to be a
Would
user
this parameter, for instance, be the distance from the surface? So 52 millimeters, 55 millimeters, 57, is that what you're thinking about for the parameter? Or would it have to be relative to
focus height? Whoops. Helps if I can spell. Okay, focus height.
Okay.
And I'm going to say by default it's 50 millimeters.
Yeah.
And this is from ground plane. Okay, this is going to get a little bit complicated, but bear with me. Because you're absolutely right. We shouldn't use a slider joint here.
Yeah.
Okay, so what happens here is so let's measure from this bottom surface to no, that didn't, that wasn't right.
56?
I can't use, no, that's wrong because I can't use the annular ring like that. I have to make sure I get the plane.
Oh, right.
Plane. I thought I could cheat, but I can't, it seems. So that distance is 55.8 meters. So,
Wow.
and that is with the laser down as far as it can go. So I'm going to go back to.
Is that going to be your minimum now, or your? You put in a 50, right? Now you're going to use the 50.
Yeah, I'm going to modify that value.
Yeah. In your
so-
parameters, yeah.
Yeah, so the focus height, I'm going to say is 60. Okay, now you got to think about this. We're trying to do a constraint.
Are we going to be doing the movement of the lens relative to the laser housing, or will we be assuming the entire housing goes up and down?
We assume the entire housing goes up and down.
Okay.
Oh yeah, I forgot. Is there a threaded focus there too? No, I just moved it up and down.
Yeah.
Oh, the thread focus, that's just for getting the shape of the dot. Sorry, it's actually been 2 months since I've turned this silly thing on. Maybe more.
Ditto.
It was before I went back east. I took it apart to start making this model, and I got the replacement wheels, replaced it, saw that it runs straight. So I actually do want to play with it again, but I haven't got to. Let's see, how should we do that though? So we still need to make sure that we constrain it appropriately. So it is still going to be a slider joint. So we're going to create an as-built joint between the laser carriage and the laser mount. And the position is going to be here.
Yeah.
Going to be, yeah, the thing is we actually kind of want to lock it down, as you were saying, but we can actually, to do that, we can just change this, because trying to figure out how to do this, because it actually is a sliding joint, but we want to be able to fix it at times. What we can do, I got it.
Okay.
Minimum is minus 20. Maximum,
Is that the range of the slots, 20 millimeters?
yeah, actually 15, I think. It's between 15 and 20. We say 15.
Okay.
And rest is going to be, see if we can do this. Focus height
Oh, wow.
minus $75. If I did that right. Does that even make sense? Let me look at that again. Hang on.
I don't know, I'll just slide it and find out.
Okay, let's see what happens. We should be able to slide it. There's the limits. Oops, that limit doesn't
Not
work.
the top limit, right?
The top limit's working. The bottom limit isn't working.
How far does it go?
It
All
goes,
the way to past the ground plane.
so there's something.
What was that 75 you were using?
Okay, let me go back to what was my parameter for focus height was 60. Okay, so when I edit the joint limits, should be 60 minus 75 should be minus 15 as my rest, but my maximum should be 0. Now, did it do something odd to me there? Yeah, that's why I put something in wrong there. So basically, there's my limits.
That's
But when I let it go, it goes to whatever focus height we've set.
pretty cool.
So now, I can grab this thing and move it in Y. I can move it in X. And when I want to, I can move this up and down. And if I modify the parameter focus height to be focus height minus 75. Let's say I make this 70. Is this working right? Now, I have something inverted there, but because the number's not going right. But the point I wanted to make is we can use a parameter to control these limits.
Where when it was at rest, it would be in focus for whatever focus height we needed. Say we had different materials or thinner materials, or it was elevated above a material, the rest position would be the focus position for whatever that material was. Is that?
Yeah, well, what we could actually do, what we could do is, if we wanted to get fancy, we could say, well, we could put in material thickness as the parameter and make it adjust automatically to whatever material thickness we said.
That's cool. Yeah, okay, great. And that just presumes that the material would be resting on the same plane as the legs of the laser.
Right, right.
Yeah, got it. Cool. I just love the fact that you can move it around and it's so close to reality. Sam's goal of having it at least look like it would actually be in the real world.
Yeah, and with these as-built joints, the animation doesn't work quite the same, but I will send you links to a couple of videos on YouTube with different kinds of joints where they're built in. And another time we'll do a different kind of joint rather than doing these as-built joints, because the animation is pretty straightforward then. It actually looks really cool. It goes through motion, and you can do even the belts and things like that. You can define how things will move.
Can you describe how we should understand the words as built in what you're just talking about?
As built is referring, because I'm using the as built joint here, basically what we're doing is we're taking a model in which everything's been created in place, but without joints.
Okay.
And we're adding joints in after the fact, rather
I
than
see.
as part of our design intent as we go along. If
Got
we're,
Okay,
if
thank
we're
you.
designing something from scratch and we're wanting to capture our true design intent, then we're going to do everything Sam has suggested tonight. He's bang on with that. But if we are downloading stuff, which I know a lot of us do, if we are capturing something that perhaps already exists because we want to play with it or something, we don't actually always need that level of detail, and I don't want people to run out of steam putting in a level of detail that they don't actually need.
Right, right.
So for
Okay, got it.
example,
Yeah.
I put in already way more detail than I actually need. What I really want to do with this model is I don't like this mounting plate, because I find, at least with the 20 watt, that the 50 millimeter focal length is too great. And instead of a dot, I get a slit. And so it's like I'm, you know, writing with calligraphy in one direction, you know, or an old ballpoint pen, not a ballpoint, or a line point tip. So it's like a millimeter or more long and 2/10 of a millimeter wide, or 1/10 of a millimeter wide is what the beam looks like.
Yeah.
But if I go down to like 10 or 15 millimeters above my work surface, then it gets closer to approximating a dot, and I get better resolution on my grayscale photography.
Okay.
And the other thing is that if I'm not careful, like the laser will cock, and if I don't have it the right way, it'll interfere with the Y rail before the limit switch gets hit. Then the thing sits there and tries to get there. So I want to design a nice 3D bracket that takes care of this for me and make it on the resin printer. Or a combination of the resin printer and laser cut acrylic.
And when you said 3D, we're just talking about like 3D printing it. It's still going to be a bracket similar to what's there, but with a different range in the slots. Is that correct?
Right, and I might have alignment rails in it so that it stays oriented up and down.
Got it. Okay. So you won't end up at an angle at any point because it was tightened while tilted.
Correct.
Okay.
Right, and actually I'm also seeing a tilt the other way.
Towards the rail?
But I think it has to do with the tightening of the wheels. But this plate bows.
Yeah.
If this plate bows, then there's like the laser goes to the right or the left, not just front and back.
Yeah. Yeah.
But you know, it's a $200 laser, and I'm being really critical.
I know. We have gotten a lot of mileage out of this little toy.
I barely used it even. I've spent more time modeling it than I have using it.
Right. Well, and Jim went ahead and built a whole housing, right? I know I've done several hacks. Doug has spent all sorts of time coming up with things and sharing them. Yeah, it's been a good thing to build around.
Yeah, yeah.
And Tim, on mine, I noticed that the two screws that hold in the laser were the only points touching the laser. So the laser almost acted like a diving board from those two screws. So I put a couple of jack screws way down near the bottom of the laser so that it made it rigid in the, whatever that would be, the Y rotation axis.
Yeah, I thought of that too, and I drilled a hole down below. I was going in the same direction, and I thought, you know what, I want to like make something custom that's going to solve all my issues. Because I thought of the same thing that you're saying, Jim, and that's a good idea to kind of stabilize it. Needs that
Jim,
third
why
point.
did it have to be at the end of a Fusion 360 session that you let that little gem fly? I mean, why don't we know about this on the forums and stuff, man?
I
That's
put it
cool.
on about 3 weeks ago.
Oh, oops, right back at me.
And I may be wrong, but I thought you read it.
I maybe did. Sorry about that.
Yeah, I even had a picture.
3 weeks ago is a long time in COVID world, so sorry.
It is. Plus, we get forgetful as we age.
Yeah, that too.
We would get forgetful if we were aging, but you know.
That was really cool, Tim.
Okay, so that's about what I have so far. What does anybody have? And while you're thinking about what you have, I have to go top up.
Cool. Hey, Lem. Just today I was talking with Mark. He has a gimbal on a tripod that will follow the person as they walk around the room. So if they're instructing, they'll be at one place or another. And the way it does that is that the gimbal has a connection to the facial recognition of the phone, and it is able to therefore track. And it reminded me of how amazing that Belarus 3D software was.
Mhm.
It really was a big leap for me to realize that the reason it could do that demo, the reason you could pull that demo off so quickly and easily, was because you didn't have all that processing horsepower required, since it was using a hardware, firmware optimized capability in the phone itself for doing the facial recognition.
Mhm.
Back in the day, I used to do 3D scanning using a piece of software from Autodesk. It was part of the 123D series. I think it was called Capture. And you'd go ahead and you'd basically take your 18 or 30 pictures from various angles around something, and then it would return to you a 3D image. And it all seemed so possible. It turns out the reason it was so possible was because they did all of the point cloud and texture and all that up on servers, and then just delivered to you the result. And as soon as they took that package away, all of a sudden I've been so hamstrung in making 3D models, because all the packages that are really capable require that you have an NVIDIA graphics card in order to be able to do it. And so when you all of a sudden you brought that Belarus 3D's package in, it really impressed me that the phone's facial capture software could be an API to an app and could do such miraculous things in that one use case, faces. Doesn't help with anything else. But I really appreciated you having shown us that. That was really cool.
Oh, good. I'm glad you enjoyed it. I think the phone has something that uses what they call structured lighting. Is that what you used before on the 3D scanner that you were talking about?
No, it was simply taking a myriad of pictures in a in an anticipated fashion, different heights and certain number at a certain radius with a complicated background. And from that, on the server side, they built the point clouds and put the textures on it. So it was not something you could do in the phone easily until something was built into the phone, which was that facial recognition. And that was just really cool. I want to capture more things in 3D. Us using Fusion and everything we're learning here is phenomenal from an engineering perspective, but there are just things in the world already that maybe they're a dilapidated fountain gargoyle in Balboa Park, and you want to recreate it. And you would most easily do that through scanning it, building it into a model, and then fixing up that model, and then reproducing it from that model. And those kinds of things I'd like to get better at. and yet I find that the processing power required, all of my good PCs don't have NVIDIA cards, and all my old PCs with spare card slots just aren't up to the horsepower needed to do everything else. So it was just on my mind, Lem, that I thought that was a really cool demo. I just wanted to say thank you. It's really amazing what that software can do with faces. Tim, it has nothing to do with your SIG.
That's okay. It's
Is
all-
anybody working on anything like building a model of something they're building right now with Fusion? Or are you guys all in learning mode?
You mean, are we using it to actually design something that we want to build? Yeah, well,
right.
I mean, you know, for 3D printing and little fixtures and small projects, I use it just to try to get some you know, experience in using it, because it's the only way.
Right.
Yeah, I've built quite a few things for 3D printing. Not too much for CNC so far.
Yeah, but you're comfortable with the workflow for the Shapeoko, or I mean, would you be able to do that based on either your experience or what you've seen from Mark or Tim?
Yeah, I have learned a lot more about how to do the manufacturing part of it, and I have it's a simple thing, but I was laying out a board with the screws that you put in, so you can put kind of like Moy did on some of his videos, where he made a board and he put holes in it so that you could what do you call those?
Yes,
You mean a
cards
threaded
and thumb drives
baseboard?
and stuff.
I'm sorry.
I saw one where he put one up with SD cards and thumb drives and things like that. Is that what you're talking about? It's just a place to keep all this clutter.
Yeah, he made it. Well, not that so much, but he made like an MDF board, and he drilled holes in it, and then he made it so he could screw down his parts for work holding.
Threaded baseboard.
Threaded, yeah. That's what I'm
Threaded
sorry. That's
baseboard, actually.
a threaded inset, yeah.
Yeah.
Insert,
I
a
did
threaded
that
insert.
too.
So I designed that for my Shapeoko, and I also made it so that I could do the shade down the MDF so that it's all level. So I did a couple of things in Fusion 360 for practice, and it was kind of easy to do, so it was great practice to do that. But having done that, now I've learned how to sort of the steps involved in doing the manufacturing part.
Yeah, because it was really that G-code portion that I was, because you know, that whole, when we saw Tim do the simulation and then export the G-code, that's the only time that I've seen it, and I don't know that I could recreate it. I was doing a project just yesterday or the day before, and I got a little bit frustrated because I can't remember the exact reason, but between all the packages that I was using, which is Carbide Create, Meshcam, and vCarve, couldn't get it to do quite what I wanted. And I was thinking maybe Fusion, and I backed away because I didn't know that I could do the tool paths and get the G code out of it. It's too vague still for me, but you're able to do that, Lem.
Yeah, it's not too bad actually. You create something called what they call a setup. I don't know if you covered that in your class, in this class.
Oh,
you make a setup, and then in that setup you can define your tool paths. So the first thing you do is do a setup, and you define some things in the setup, and then you choose a bit or a tool, and then you decide what parts you want to cut with that tool. And also in the same setup, you can define additional tools.
Yeah. I have to admit that I was just remembering that there were a variety of tabs, and it just didn't seem like it was nearly as, well, it wasn't familiar, but it also didn't seem like it was as obvious as the things that I'm used to. I was just curious. Sam, have you used the?
You know, yes, I think it was yesterday. I just started taking a look at the manufacturing, and I wanted to, you know, I was importing the tools, you know, the carbide tools into
Yeah,
Fusion
yeah.
360. And so I'm just starting to look at that now.
Yeah. Okay. All right.
You,
What are we looking
you
at,
always
Tim?
need to get something done, and a way to do it, you don't want to be trying to learn a new tool and when you want to get something done. So that's
Exactly.
Oh, that's usually what forces you to learn it.
It is
right,
true.
but
I mean, that's why you volunteered to do this SIG, right, Tim? You wanted to sort of get Fusion under your belt. What better way than to teach it?
Exactly. No, it forces me to figure a few things out. I struggle sometimes with a little bit, but yeah.
I can't remember, Tim. Do you have a CNC?
I don't. I'm going to take
Okay.
the course starting this weekend and start using the
that's
shops. I would love to get one. I don't think I quite have room for it.
Yeah, space, always an issue.
yep.
This is,
I agree
but this
with
is one
that.
that you set up for milling? This particular project we're looking at on your screen, is that for a CNC project?
This is, I make a picture of this and use this as one of the bumpers on the video.
Okay, all right. Got it. And here I thought you were doing CNC milling.
No,
Welcome
no
back,
such
Jim.
luck. I would like to be there, but
Well, it'll be interesting to hear your reaction to VCarve once you've become familiar with it, because it's so focused on woodworking. And
right.
it'll be curious, given the versatility you know of in these more agile packages, to get one that's sort of so locked down to a particular type of tool and a particular type of set of materials. Yeah, I'll be curious to see how that goes.
Yeah, I'm looking forward to it.
Good. Anything else, guys?
If you want I came across a fairly inexpensive CNC machine that's small, if you're interested in learning, hearing about that.
It's an interesting idea. I've kind of toyed with, how big does it need to be useful?
Depends on what you want to do, I think, I guess. If you want to, for experimentation purposes and something about the size of a printer in your office, you can buy those.
And then what's the work surface or what's the work area like?
The thing I came across that looked pretty neat was a Chinese CNC product made by SaneSmart, and it's the 3018 Pro. It comes with a gerbil board, just like the Shape Elko does. It's got a touchscreen interface. It's got some acrylic panels on the side to keep the chips from flying off. You can even buy an enclosure for it to make it quieter, and it costs less than $500. So it seemed like a pretty good deal, and it had good ratings on YouTube.
Oh, that's interesting. Yeah, I should think about that.
3018 Pro.
3018 Pro.
Let me just share with you guys, originally when we started talking about doing build groups, we talked about doing a 3D printer, because that's a very common build group that people get around. And you just learn so much when you build it, and you build a community around it, much like we're doing here with Fusion 360. We didn't end up going down that path because it wasn't as appealing a product for people at the shop. But we spent quite a bit of time trying to figure out what CNC we could build. There was something from Craft CNC, which is a Vectric spinoff, and it was 3D printed, but unfortunately it required metric acrylic in order to get all the dimensioning right, so we couldn't do that. We looked at one that was called it's made of pipes. All 3D CNC or something like that. And the reason I'm telling you all this is because we ended up then with this laser, which was a very easy assembly, but many good things spun out of it. I mean, Tim's putting this into the form of a way of teaching us joints, and the work that he's done building up to this is just a great example of how something like that can be used. We've had all the other examples, from Jim's housing to Doug's hacks to other people having done things. And the reason I'm saying all of this is because, Lem, you just brought up the idea of a CNC that was $500. The idea that people can learn so much and we can develop such a community around a tool like that that is maybe price-wise accessible to people and is hackable, and we learn just because in the assembly process there's time we need to spend together and we have a common base of knowledge and that sort of thing. We already have almost 100 people trained in CNC, and only a small fraction of those actually own them at this point. But I guess I'm curious, was that SainSmart CNC something that was a kit, or was it a pre-built?
I can show it. I can bring you up on screen if you want to take a look at it.
If Tim would let you do that, yeah.
Yeah, that would be great.
Can you share screen?
You may need to give him, yeah, okay. Why don't you let go of it first, Tim? Up at the top center of your screen.
Oh, I
Or top left.
top share, yeah.
There you go. There we go.
Made him host, but okay.
Okay, there we go. Are you guys seeing it?
Yep.
Yeah, yeah. Got a little zeroing touchpad too, which is cool. I bought one of those once from China. It was $3.72.
So yeah, the cool thing about this, it gives you everything you need, and I think it's largely assembled, or so it takes 15 minutes to assemble it once you open the box. So
Can you go full screen on the image? I mean, if you click on it, does it go full screen? No, just the image itself. Yeah. Can you click on it? There we go. Okay. So touchscreen UI is kind of cool.
and there's a little gerbil board on the back. You can't see it, but in the back there's a gerbil board that handles the motion control.
I'm sorry, you're saying GRBL, right? Gerbil?
Gerbil, yeah. I would say gerbil.
Yeah, okay.
I don't know why. I guess because of the animal gerbil. Yeah, the gerbil board.
Okay. And, it looks
And
as
you
though
got
it has,
it's a lead screw, which is kind of nice.
yeah, I see it's got 3 linear rails too at the bottom for rigidity on the y-axis.
Well, one's probably a driving rail, right?
Yeah,
Right, the middle one. You can see the
Right.
stepper motor in
the
the back.
rails and the lead screw, yeah.
Oh, yeah, you can see the stepper motor in the back.
Yeah.
Is that an e-stop on the right side?
Yeah.
It's cool. And what was can you see the dimensions? If we go back, what the cutting area is, X, Y, and Z?
Let's see. Okay, there's 10 inches by 6 inches, and then the 1.4 inches of travel.
Okay.
Pretty small.
That's before you put in that spoil board, but yeah. Can you go up and show us some more of the pictures?
I wonder if you could step and repeat, or offset.
I mean, to get larger cuts, you mean?
Yeah,
Use indexing? Yeah,
use indexing to do a larger workpiece.
right.
I think in the Y direction you could.
Yeah, the X direction on
Right.
it.
Yeah, because it's open in the back, it looked like.
Here's some other models as well.
Yeah, the laser model.
Right. But $350, was that the price you were originally thinking, Rim? Because that's pretty good.
Yeah,
But you had said 500. Were you thinking about a different version, or?
I just was just sort of guesstimating off the top of my head, but trying to remember what I had seen.
Okay.
You can buy some other parts with it, and it does bring it on up to closer to 500.
Yeah, yeah.
They have some other versions of it that have different sizes of working areas.
Yeah. Cool. I guess I'd be curious. Maybe I'll toss a note out there to the CNC community and just see if any people would, just based on what happened with the Ortur and lasers and how far that went. I just don't know if the same thing would happen with CNC, but it's a great thing for a community to rally around a shared project like that. I'm a real fan of that process. This is what's the URL of this place? Just sainsmart.com? Okay.
Yes, Saint Smart. Somewhere on here they have an enclosure you can get also for that to make it run quieter.
Yeah.
Oh, here it is.
There you go.
Oh, yeah. Sold out. The world knows you want these things to be quiet.
So it's a 99% reduction in loudness. So I'm pretty impressed by that.
That's pretty hard to believe. Jim, do you have a CNC?
Me?
Yeah, Jim. Yeah, that Jim. The only Jim on the call.
No, I don't, but during robotics, I have access to the school's CNC,
Right.
which is 4 feet by 4 feet. And it's
Oh, nice.
it's a significant improvement over our member shop's CNC.
Yeah.
Of course,
And Lem, is yours a Shapeoko? Yeah.
They,
Big pardon?
I
Did you have
don't,
a Shapeoko? Is that right, Lem?
Yeah, I have a Shapeoko XL.
Okay, and that's what you have too, Sam, right? XL?
Yep, that's what you had.
And, yeah. I know we have a relationship there. I have just I have the small one, the 3. And Tim, just so you know, after you take the class, while you'll be introduced to VCarve, you'll also be introduced to the Shapeoko family, and those can get you started at around $1,100. Quite a few people on it's obviously not a kind of thing that Jim would get his 4 foot by 4 foot cutting done on, but it's really well understood in our community. Just one of those things where, much like Sam's and my laser, a lot of people have lasers in that family, and once you get something along those lines, you have so many people you can turn to ask questions, to find out how they fix problems, to teach people and advise them on. It's just a really neat aspect of being a part of this community.
Yeah, it's something I've thought about, the trade-off between laser and CNC for doing some of the acrylic stuff to get better accuracy and straighter cuts and more accurate Z-axis control.
And since you don't have a shop you can send it off to inside of the companies you worked for and just have other people do it for you, huh?
Yeah. Now I have to figure out how to do stuff myself.
Oh, I'm so sad. Anyhow, I don't know if there's anything else you had lined up, Tim, but I was just curious about some thoughts from the team here. And Jim, did you have a thought, Jim?
do I have any thoughts? Well, I did have a question. This second time I've heard people say they have cut the plexiglass with the laser. I tried that with the little Ortur, and all I did was just kind of burn it. Is there some trick that a novice like me?
Well, I mean, you're not going to get a lot done with the Ortur, but it's really critical what the color of the acrylic is. I have been able to cut really thin. Can't remember what color, but on other ones, it just the color of the blue light just is absorbed as heat. So it's an interesting factor that the color makes a big difference on how the material is affected. And do not have great expectations for being able to cut very thick acrylic. I think mine was probably 1/16 or 1/32, very, very thin stuff.
Okay.
And when I was talking about cutting it, I was talking about Sam and I have 50-watt lasers in addition, like the ones at, well, it's not quite like the ones at the shop, but the same family with the same controllers and same CO2 technology, the big tubes, that sort of thing.
So far with your tour, I've cut paper.
Yeah, and well, right?
Well, it's really more for engraving, I think.
Yeah.
It really is. It really is. Yeah, I agree.
And
I
that
agree.
was-
You can do some nice little pictures and stuff. I did for Mother's Day. I did a nice little photo for my mother, and it was a particularly stressful time, so it was particularly appreciated.
Yeah.
and I
Well,
was
the
trying to
engraving
cut
is the one thing you can say it does well. I'm sorry, Jim?
I was trying to cut the UV shield plexiglass,
Yeah.
which probably is pushing away all of the laser. As the laser beam is trying to get into it and cut it, the UV laser acrylic is trying to push it away. So that probably.
Oh, right.
Right.
can't
Looks
get
like
through it.
Lem is doing some shopping right now, taking us to open
I guess
builds.
I guess the other place I would look if I was looking for a CNC would be open builds.
Yeah.
And it's more of a kit. You have to do all the building on this, but they have a lot of different options, and you can also kind of
They do.
customize the type of machine you want.
Yeah.
Have
Yeah.
fun.
It's also well supported. It's kind of like Shapeoko in a way, because they have a lot of support in terms of tutorials and videos.
And a big community.
A good community.
A big community of people. Yeah.
Yeah.
I mean, a lot of their products actually get designed by the community and then make it into the shop here. It's pretty cool.
And they have a Gerbil controller that I like a lot, the black box.
Oh yeah, yeah, yeah.
And they also have some software to go with it. It's kind of like Carbide Motion.
Oh, is that right?
Yeah, it's a pretty nice package. They're similar, very similar to Carbide Motion. I think their black box is a little bit better controller than the Carbide 3D box, actually.
Probably. Carbide 3D is just the Arduino based thing.
Yeah, well, this one is too, but it's
Oh,
it's a little bit better. For instance, they have a 10-volt analog output for controlling your spindle speed.
Right, right. Yeah, that's something I've considered. Sam, have you ever considered that? I'm not trying to drag this out, but Sam, have you considered getting a spindle?
Yeah, at some point I would like to, but I need to get, to use it a lot more, I think, before I take that step. I'm
Yeah.
space limited, so.
Yeah, I've thought about it primarily just as another learning exercise. Like I just got the camera for the laser that you can actually position work, see it, and then say where on that work you're going to be doing.
That I was going to do.
Yeah,
I was going to do that. I haven't done it yet, but.
Yeah. Well, Tim was finishing up his scotch there, so.
Yeah, running low on scotch here, so we're almost out of time.
All righty.
Jim, thank you very much, man.
Yeah,
2
thanks
weeks
a lot.
Really,
Jim.
there's still a bit left.
There you go.
Great.
The night is young, Tim.
Hey, thanks for coming out, guys. Great to have a session again, and we'll see you in 2 weeks. Anybody have any ideas on any suggestions for topics, or should we just dig deeper into joints and animation?
I guess animation is what stands out in my mind.
Animation would be good.
Sorry, Jim?
I think animation would be good.
Okay.
Yeah, yeah.
I'd like to see that. And the topics that you have chosen, Tim, I thought you've done a great job. You expose us to things that, of course, I never knew about. So I think you're doing a great job picking it out, but I realize you're probably running out of topics that you think would interest us.
Well, the tolerance band between what I'm showing you and a little bit more that I have to answer questions is pretty narrow, as you may have detected. So I basically learned enough to show you what I'm showing you, and when
with 25 to 30 years of experience behind it.
well,
Right.
yeah, on a different package, and then when smart questions come up, I have to use a little smoke and mirrors and conjecture and figure it out on the fly.
Well, we are very fortunate.
It'd be nice
Sorry,
to cover manufacturing. I know you don't have a CNC, but maybe if you start working with the Shapeoko at the shop, we could go through a project or two just to see how to set up a CNC job.
Yeah, that would be
That's a
cool.
good one.
That would be really nice. Yeah.
Yeah, yeah, yeah. What I was saying a second ago is, Tim, I was talking with Dallas earlier today, and we were just saying how lucky we are to have been given this gift of CAD knowledge from you.
Well, I'm glad it's useful because, that's the way I feel about the club. It bugged me that just about the time I figured it out and started getting involved in the club, everything got shut down.
There is some ugly irony in that.
There is some irony there, but that's not, obviously, if that's the worst outcome of it, that's not bad.
Yeah, right.
And it is.
Well, these Zoom sessions for these kind of it's class, I guess, but it works great. I think it's even better than meeting in the shop to have classes like this, because you could show things on the screen. I could actually hear well, because my earbuds in. you have it taped, and so you can go back and look at it again, and so there are some positive things that came out of necessity, and
Yes. But Sam, what is this thing you refer to as taped?
well, recorded.
We all know where you're coming from, buddy.
Hey, I've used core memory, magnetic core
Yeah,
memory. Where you can actually see the bits.
Hey, that'd be a good CNC project. Cut out some little magnets. Yeah, wire them together.
Okay, boomers.
All righty.
Thank you,
Thanks
guys.
a lot.
See ya. Bye-bye.
See ya.
Bye.
Bye-bye.
Len, I think you'll have to close it down.
Okay, let's see, where am I here?
You end the meeting because you're host.
Okay. So I'll be ending meeting for all.
Yep.